Hi there. So I'm going to talk about something a little bit different this update. I was teaching for a couple of weeks, so I've not really done anything super shiny. What I have done is finish off the dialogue system, and that touches on a couple of things that might be interesting, so unlucky I'm going to waffle on about those. Caveat, I'm definitely not saying any of this is the right way to do stuff. I've not written a lot of this stuff before, so there could be better ways. But this is what I've landed on, and it works. Ship it. First up, how I handle action buttons in the game. So UE4's opinionated about how it splits up the game framework, and one of the classes is the player controller. So you'd obviously always end up with something like this, even if it's just a component that's attached directly to the player character, which is what I had in Lumo. The downside, which I also had in Lumo, is that the controller becomes massive really quickly. So when I started this game, I knew I was going to have a lot more discrete character actions, and I was worried about building up a single massive class with a big old finite state machine in it that handled every case. I wanted something that would be a little bit more flexible and componentized, especially for things in the world that the player has to respond to. So I built a bunch of discrete action button responders. The way these work is that they register themselves with a game instance and then grab or respond to button inputs that are passed from the player controller class. So, for example, the player walks into a trigger area. The trigger area could be for something like a sign or opening a chest, and that object has an action button responder attached to it. On entry to the trigger, the action button responder registers itself, and the object might do something like show which button you need to press, so there would be an icon that would appear on screen. The action button responders themselves then act as tiny little finite state machines. The player presses a button, the player controller immediately passes this input up to see if there's anything registered and if they can do anything with the input. If so, they then run their course and the player controller can ignore the input entirely. If not, then the player controller is in charge at that point. It'll do something like, swipe the sword. So for something simple like a sign, the player controller gets the input, passes it up, and the responder does what it needs to. In this case, it will lock the player character in place, and it will tell a message dialogue to appear and pass the correct string. It then changes what button it responds to, so basically any button would work to clear the dialogue, and the next time that input appears, it grabs it and it tells the dialogue to disappear. Now, all of this could be done in the player controller, but that would mean it would get quite hairy quite quickly, and it would need to know some context about what the world state is, and I didn't really want to get involved in all of that. This way, the responders can register themselves when they need to and deregister. So for something like the sign, it just deregisters when you exit the trigger area. If they're activated, they run their course and they handle the inputs as needed. And technically I can stack these up so multiple things could respond at once, but in reality I can't ever see me needing to do this. So yeah, for things in the world, this turned out to be a really nice pattern, would use again. Which brings me to dialogues and text. Lumo was a game that ostensibly had no text in it, but all of that UI stuff, error messaging, high scores, did need to be localised, and we only did 7 or 8 languages, but I knew it was going to be a ball ache. Lock is never a one-shot deal. You send stuff off, get things back, someone notices a mistake and the whole thing iterates again. So someone at the publisher can't use source control, you end up with lock version 1 final.zip. The translators see the game, they want to make changes. Basically it iterates, and it iterates a lot. And obviously Unity doesn't provide anything useful in this regard, so I was forced to roll my own system. What I ended up with was a LibreOffice spreadsheet with all the text in, with columns for each language, and a Python script which parsed the spreadsheet and generated a C# class that contained all of the translated strings in language-specific arrays. The game just picks the locale on launch, which decides which array we're reading from during the game. The strings in the array are just referenced by an enum, which maps to an array index basically, and all of that's just auto-generated by the Python script. Best thing about this was it worked. Every iteration I could just run the Python script, generate a new class, push out a build with a new localization in. 2 seconds for the generation, 45 minutes for each build, nothing hydraulic on my part. Now, UE4 has a localization system. I would guess it's pretty powerful, but I've gone through the docs a couple of times and nah, it looks like an almighty faff and way overkill for what I need. So I've gone back to something similar to my Lumo system, but with some small changes. Instead of building a class, I can import a CSV directly into data tables, which are one of my favourite bits of UE. Now, a data table is just a populated structure. It's easy to pull out rows in code. So this time I've got a Google Docs spreadsheet that's split up into a table for identifiers, which is like names for NPCs, pickup items and stuff, and one for dialogue text and one for conversations. So a conversation is just several rows of dialogue text. I'm not doing any branching. I'm very rarely asking a question, so it's all basic stuff like, here's a message, now you're on a quest, or here's a message, you've just picked up something you've not seen before. I can build these like multi-line conversations just by listing a bunch of dialogue string UIDs in a table and then running through them in code. The spreadsheet can be passed around to whoever, and all I'll ever need to do is just basically generate one header file which has these UIDs and an enum, which is exactly the same thing as I did for Lumo. So in theory it should just work. So this month I've done all of that apart from the script which generates the header file, which I'll do at the point that other people get involved. The other thing that came up in Lumo is that the translators really didn't like playing the game to see their work in order to look for problems, so I've written a little debug system for this. You can pop open the secret squirrel menu and click on any string or conversation ID to see how it looks in a text box. It doesn't warp you to the location in situ in the world, but it should be enough for people to see how things look on screen basically. And it's quite nice for me as well. I can, just really quickly iterate on stuff. So yeah, that was the big ticket items for this month. Oh, and I made some butterflies. So yeah, thanks for watching. Hopefully next month I'll have something a little more shiny and less technical. Bye.